Senior Statistics here, about to drop some knowledge on the world of statistics. Today, let's look at observational versus experimental studies. An observational study is a study in which the researcher observes characteristics of a sample selected from one or more populations, where an experiment is a study in which the researcher observes how a response variable behaves when one or more explanatory variable or factors are manipulated. Now, what this goes into is showing cause and effect. Okay, let's just look at this example. In this study, two groups of children were followed for 4 years. 806 children ages 2 to 4 and 704 children ages 5 to 9. The IQ was measured at the beginning of the study and again 4 years later. Researchers found that the average IQ of children ages 2 to 4 who were not spanked was 5 points higher than those who were spanked, and 2.8 points higher for the children ages 5 to 9. So the question is, does spanking cause the decrease in IQ? Why or why not? So this is a little bit more of a loaded question. Okay, we need to actually see what can be used to determine cause and effect. Okay, we need to be able to notice if there's any confounding variables. A confounding variable is a variable that is related to both group memberships and the response variable of interest in the research study. Because observational studies may contain confounding variables, their results cannot be used to show cause and effect relationships. Alright, an observational study can be generalized to the population if the sample is randomly selected from the population of interest, but it cannot show cause and effect relationships. So if we actually look back at that case, all they did was looked at these children and saw if they were spanked or if they were not spanked and got the results. They did not say this group had to spank their kids, this group didn't have to spank their kids. Right? So this study was an observational study. It was not an experiment. If it was an experiment, they would have assigned a specific set of people to actually spank their kids and another group to not spank their kids. So because of this, we cannot say that the spanking causes the lower IQ. Now, again, observational studies, you can actually take all that data from there and generalize it to the population as long as the sample is randomly selected. If it is not randomly selected, you cannot apply it to the population. But you can never show a cause and effect relationship from an observational study. It has to be from an experiment. So, well-designed experiments can show these cause and effect relationships, but you cannot generalize it to the population if the groups or volunteers are not randomly assigned. Now, you can have experiments that show cause and effect relationships and be generalized to the population as long as you randomly assign the groups. Again, there's a matter of having randomness in these problems to show generalization to the population for both observational and experiments. As long as there's something random about how you pick the people, then you can apply it to the population.